Now we're on to my favourite topic in maths, which is differentiation. So some of you have encountered this before at GCSE Further Maths. For the rest of you, this will be brand new. But trust me, this is such a lovely topic. So I'm just going to go through some of the basic notes with you and point out some of the important concepts. So it says at the top, refer to PowerPoint and first principles. If any of you are interested on where differentiation came from, how it was derived, please look at this PowerPoint. Ask your teacher if you need any more clarification. But basically, the whole point of differentiation is to be able to find the gradient of a curve. So dy by dx is what we call the gradient of the function. Okay, and all this is a formula by which the gradient at any point, so remember the gradient of a curve isn't always the same, not like a straight line. So using dy by dx we can find the gradient at any point. A few things to note: dy by dx does not mean divide. It means we take our y and we differentiate with respect to x, and you're going to learn how to do that very shortly. So to differentiate any function, remember this one sentence and you will be able to do anything. What you need to do is multiply down by the power and take one away from the power. So if we look up at the general example, we have some function y equals xn. We need to multiply down by the power of x. We differentiate everything with respect to x. So we multiply down by the power, which is the n, so it comes down, and then we subtract one away from the power, so it becomes n minus 1. And that is true for any function. So we're going to go through a few different examples and talk you through how to differentiate the basics before we put this into practice. Let's have a look at the first example then. We've got y equals x to the power of 4 and we're asked to differentiate it. So that means we multiply down by the power of x and we subtract one away. So we're going to multiply down by the 4 and take one away from the 4, so it becomes a 3. So the differential dy by dx, so it's important we put that in, dy by dx, the differential equals 4x cubed. Part B, we have y equals 5 and we've been asked to differentiate this. Now remember, when we differentiate we do it with respect to x, and there is no x term here. So if we're differentiating any constant, so anything that doesn't involve an x, this is an important one to take note of, the differential is just 0. So example C, just taking it a step further, our x term now has a coefficient greater than 1, so we've got 2x to the power 7, but the rules are still the same. We multiply down by the power, which is a 7, and then we'll take one away from the power. So multiplying down by 7, we get 2 times 7, which is 14, and taking one away from the 7, we get x to the power 6. So our differential dy by dx is 14x to the power of 6. So for part D, I want to draw your attention to the way we've been given this function. We've been told that y equals 6 root x. Now when we're differentiating, we need to have powers of x as we differentiate with respect to x. We're going to need to use our knowledge from index notation to rewrite this. So remember that the square root of anything is the same as writing it to a power of a half. So if we just replace that with y equals 6x to the power of a half, and we'll be able to differentiate from there. So remember, we multiply down by the power, so we're going to multiply down by a half, and a half times 6 is 3, and then we take one away from the power. So we get dy by dx equals 3x to the minus 1/2. A half subtract 1 is minus a half. Now we can leave it like this, or we can rewrite it. So remember, minus a half is the same thing as writing it as 3 over x to the power of a half. Again, look up your index and your surds notes if you're not sure. And putting it back into the same notation as the question give it, we can rewrite the x to the power of a half as root x. So we have our final answer, dy by dx equals 3 over root x. On to part E. Here we have a slightly longer equation to differentiate, but just take each term individually and differentiate them one by one. Using our rule, I'll say it again, it's going to be stuck in your head. multiply down by the power, take 1 away from the power. So let's take the first term. Doing that, we will get dy by dx equals 12x squared plus 4x minus 7, and remember, the minus 2, we differentiate, it becomes a 0 because it does not involve any x terms. Part F, again, we need to write into index notation. We don't want the x as a denominator in a fraction, so if it's ever trapped within a root or in a fraction, use your rules of indices and get it into index notation. So instead of writing it as 1 over x, we can write that as y equals x to the minus 1. So now we have it in a format that we can differentiate. Let's go ahead and do that. So dy by dx should equal minus x to the power of minus 2. Again, watch out for the negatives. Minus 1 take away 1 is minus 2. And tidying that up, we would get minus 1 over x squared. Part G, again, we need to rewrite in index notation. We have y equals the cube root of x. We can't differentiate it when it's in this format. So again, indices, notes, go back and read over them if you need to. Rewrite it as y equals x to the power of a third. And from here it should be straightforward enough. Multiply down by the power. So multiply down by the 1/3 and take 1 away from the power. So we end up with dy by dx equals 1/3 x to the power of minus 2/3. Now if you want to tidy that up, you can. So we would have, instead of 1/3 x, you can write it as x over 3. So I'm bringing the negative power down. We would get 1 over 3x to the power 2/3, which is the same thing as 1 over 3 cube root of x all squared.